We're going to talk specifically today first about vertical asymptotes. Okay? Talking specifically about vertical asymptotes. Yesterday you talked about what an asymptote was. So tell me, what is an asymptote? That thing. Can you elaborate slightly? Okay. Nothing. That's a better definition, right? Can you elaborate slightly? So a space in between things on a graph? That's okay. What lives at an asymptote? What lives there? Nothing, right? Nothing lives where an asymptote is. That's what makes it an asymptote. Okay? Yes? All right. So let's look here. First of all, we've got 7 tables that we need filled in. Can we fill in these tables like we have just recently? Okay? So who's got 1? Who's going to do number 1? Hayden's got 1. Who's got 2? Aaliyah's group has it. Number 3? You got 2 and 3. Y'all do 2 and 3. Who's got 4? Y'all have 4 also? Okay, you guys got 4. Who's got 5? Who's got 5? You've got 5. Okay, who's got 6? You guys have 6, and you guys do 7 also. Okay? Hey, before you get started, let me see your calculator, please. Before you get started, I need to show you something real quick. When we're putting in, let me zoom in real fast. When we're putting in rational functions, we have to be careful, okay? Because if I go to my graph right here, this person didn't clear theirs. Please make sure you're clearing your calculators every day. Menu, actions, delete all. See that? Yes, I really want to delete all. Okay? Control T. Let's get rid of the table for a second. When I put in rational functions in my calculator, I have 2 choices that are both correct, that will both give me the right thing. There's lots of choices that will give you the wrong thing. So let me show you the 2 that will work. All right? Number 1, control divide sign, the fraction. Do you see how it already makes a fraction? Yes? So we can go ahead and put in x minus 4 over x minus 2. Just like that. That looks like a fraction. The calculator sees it as a fraction and does things accordingly. Okay? The other thing that you can do is open a parenthesis and say x minus 4 divided by, and then open another parenthesis, x minus 2. Why does it make a difference? Why can I not just do this? Whoa, not that. X minus 4 divided by x minus 2. Do what? Well, it'll work, but the calculator does order of operations, right? So the calculator is thinking you're telling it to say x minus 4 over x and then minus 2. Is that what you're asking it to do? You're asking it to divide that by that, but unless you put those in parentheses, or if you put them in fraction form, like control divide, that fraction form, it's not gonna read it that way. So make sure when you're putting it in, that's what you're doing. Okay? Thank you. Once you get it done, let me know and I'll fill it on the table. Which one? Number 1, read it to me, please. Thank you. What you got? Good. Number 5. Thank you. What you got? Negative 0.25. Mm-hmm. Mm-hmm. And 2. Okay, thank you. I still need 3, 6, and 7. I'm sorry? 7? Okay. Undefined. I'm going to go ahead and put that. Is that okay? Okay. 3 and 6? Thank you. I haven't put... Wait, what do you mean? 0.416? Number 3, what you got? Wait, who's doing number 3? Who's doing 6? No, I thought you guys did. Okay, sorry. Okay, what you got? So can we do that? 0.6 repeating? Okay. Sorry. Okay. All right, there's number 6.
I have number 6.
I just did it, but thank you. Yeah. So here's the deal about vertical asymptotes. Okay? First of all, why is, looking at problem number 1, why is 2 undefined? When x is 2, y is undefined. Why is that true? What would happen if I put 2 in? What's 2 minus 4? Negative 2, right? What's 2 minus 2? So negative 2 divided by 0, isn't that just 0? Can you divide by 0? Who's the only human that can divide by 0? Chuck Norris, and he's not in this class. Okay? So we're just going to leave it as undefined. Yes? Okay? So, but that's good for us though, because it tells us wherever it's undefined, wait, what lives somewhere that's undefined? Nothing, which means that's where our asymptote is. So the undefined places in the table makes the denominator equal to 0, and so we can't have anything there, so guess what? It's an asymptote. So how do we name our asymptotes? Do I put like Bob, Frank? If we're talking about a vertical asymptote, show me with your arms what a vertical asymptote looks like. Okay? Vertical means what? Up and down. Okay? So vertical would be this way, right? Is it going to curve anywhere? If it's not going to curve anywhere, what shape is that? It's a line, right? How do we name our lines? With sometimes, but with only a vertical or horizontal, we only use one. And we say which axis it's crossing and where. Well, guess where this one's crossing? It's crossing the x-axis at 2. So x equals 2. So tell me the answer for number 2. X equals 6. What about 3? X equals negative 3. What about 4? X equals 6. 5. 6. X equals negative 4. And 7. X equals negative 2 and x equals 2? Wait, we're allowed to have 2 of them? What about 3? Yes? What about 24? Can you have 24 asymptotes in one graph? Mm-hmm. You want to see one? Let me see your calculator real quick. Mm-hmm. I don't know if it has, well, no, I know it doesn't have exactly 24 just by the definition of the function. But I'm going to show you one with more than 1 and more than 2. Okay? See that? Right here, there's an asymptote. Right here, asymptote. Here, asymptote. Here. Yeah. No, I don't. Thank you. Okay? So, is there a way to find the asymptote without having to do tables every single time? Because that would annoy me. Would it annoy you? I'll tell you something that is annoying me. Are the asymptotes related in any way to the numerator or the denominator? What do you see? So if I put this into the denominator and it equals 0, that's what the asymptote is, right? So it's clearly related to the denominator. How can the asymptotes be determined using the denominator? You said if you plug it in, if you already know it and you plug it in, it gives me the denominator equal to what? 0? So how could I figure it out just looking at the denominator with having to know it first? But I don't know it, so I can't plug it in. What do I do with this denominator to give me an answer of x equals 6? Set denominator equal to 0. Got it? Yes or no? So let's look at the other side. For each table showing the values for a rational function, identify the location of the asymptote. Where is the asymptote in this table? X equals negative 2. So here's something different. I love when they ask you questions in the homework that we didn't even talk about in the lesson. Isn't that great? Because what does it ask us? For the domain. That's the specific domain for this table, so I'm glad you know that. But if we're talking about the actual function of this domain, the domain of this function, doesn't give us an equation, but we know that it's talking about more than just those 4 points. Okay? So what we have to be able to say with some certainty is what the domain is of this function. What is it allowed to be? Anything but negative 2. Right? because that's where an asymptote is, so nothing can be there. So it can be anything but -2. So we can say all reals except x equals -2. And here's the fun part. I need you to be able to write it the other way. Here's what it looks like. I'll tell you. Write it down first. Write it down and then I will interpret it for you. It's a U. So this is what it means. It means it goes all the way to the left. All the way. Right? And then as it's coming back this way to the right, it has to stop at -2, but not include -2. See, I didn't put a bracket there. I put a parentheses, right? And then again, right on the other side of -2, but not including -2, it starts again and then goes to infinity. This says exactly the same thing as this, but what we're figuring out is this is not how it's showing up on standardized tests like ACT or SAT. This is how it's showing up. Or TSI? Is that right? Okay. I honestly don't know how it shows up there because I haven't looked into that. That's a fairly new test. Okay. So you have these three to do by yourself. Look at this example. For each rational function, find the vertical asymptote. How do you find the vertical asymptote if you have the equation? Set the denominator equal to 0. There's the asymptote. Done. Set it to 0. You add 7 to both sides and you get x equals 7. Okay? So the other kind of asymptotes that we have to talk about today are horizontal. Okay? This is a fun story, but one of those that we don't have time for. Okay? So what happens is that Charlie plays basketball and she's quite bad at it. In her free throws, she's only made 13 out of 30. Okay? So she gets with her coach and says, please help me out. And coach is like, okay, let's work. And coach helps her out. And suddenly she starts making every free throw. Well, right now she's at 42%. So how long is it going to take her to get to 80%? How many in a row does she have to make? How many in a row does she have to make to get to 90%? How many in a row does she have to make to get 100%? And some of you are looking at me like, she can't get to 100%. Why can she not get to 100%? She's already missed some. 100% means you got every single one, right? And she's already missed some, so you can't ever get to 100%. And so, thinking about that, when using rational functions, you plug in larger and larger numbers. So even if she tries 1,000,000 shots, she can still never get to 100% because she missed some at the beginning, right? That thing is, now it's approaching 100%, right? It's going to get closer and closer and closer to 100%, but not quite get there. That is called a limit. And a limit is a very, very important topic in calculus. Okay? It's something that the function approaches but never reaches. All right? So this is what I need you to know. Graphically, this makes an asymptote what kind? So now we're going to horizontal asymptotes. So first of all, it wants us to predict the locations of this type of asymptote by finding a limit. Or do it by plugging in larger and larger values for x. So we have 8 possibilities here. We're going to do the same thing. Okay? Volunteer for one. You and your table do one. You guys got 1. Who's got 2? You got 2. Who's got 3? You guys really have 3? Just teasing. Who's got 4? You have 3 and 4? Okay. Who's got 5? Yes, you've got 5. 6? You guys got 6. Who's got 7? 7. And who's got 8? Okay, you guys got 8. So as soon as you get these filled out, let me know. We'll fill them in and then we will talk about them just like we did last time. Oh, no, that's a good question. Can I see it one more time, Shad, please? So if I'm going to go first, and I'm going to make myself a fraction because I like it to look, whoa, not that. I like it to look like a fraction. Okay? So I'm going to put in 5x plus 6, and then in the denominator I'm going to put negative 3x plus 2, right? I'm going to graph it, and then I'm going to go to my table. Control T. But do you really want to sit and scroll in your x's until you get to 1,000? Okay, so we're going to go to Menu, Table, and look, Edit Table Settings. So go edit your table settings. Where do you want your table to start? 1,000. And how do you want your table to count? By thousands. There you go. Okay? Once you guys get those, let me know and I'll fill in these and then we'll talk about them. Uh-huh. Which one are you talking about? Oh. Hold on just a second. I'll answer that in a second. Number 1, read it to me. 0.9979. 0.9989. 0.993. So are you, so just read it anyways. Maybe it's an actual, like it goes to an actual number and that's not just rounded. So, it's okay. Okay, anybody got anything else yet? Number 3, read number 3, please. You said 2. Awesome. Number 7, read it. Okay, that's all right. Some of you should be used to a lot of zeros. Ha ha. 0.00. 1, 2. Is there 3 zeros? Okay. 1, 2, 4, 7? Okay. 3 zeros? Okay. 6, 2, 4. Okay. 4, 1, 6. 3, 1, 2. Thank you. That's correct. Number 4? 2002. 4002. 6002. 8002. Excellent. For what? Number 8? It depends on how your calculator's set up. Somebody's been going and messing with the settings of these calculators. Tell me what you got on the first one. I'll tell you if it's right. Nope, that's not right. Did you use parentheses? That's right. Okay. Uh-huh. Okay. 2000. Okay. 6? Read me number 6. Good. Good. 292. Excellent. Read number 2, please. 0.5027. Okay. Okay. Six. Thank you. Who had 5? Okay. 0.0083. Thank you. Okay, we ready to talk? Do you have them copied yet or not quite? Okay, I will wait. What? Yes. Okay, ready? What we have to do is predict the location of the horizontal asymptote. We have to find the place that the y values are going to, are headed toward. Okay? So if we look at this number right here, this y value, because these x values are getting extremely large, right? So if I go from here to here, what's happening? It's getting bigger. If I go over here, it's getting bigger, and here it's getting bigger. Okay? They're all getting bigger. Where are they going toward? What number are they heading toward? Which one? 1. Do you see how these are all getting closer and closer to 1? Guess where the asymptote is? 1. But why is this y equals 1 and not x equals? Well, it's horizontal first of all, but what y values are we, or what values are we talking about? The x or y? The y, right? Okay. So what about number 2? Where is this headed toward? Point 5027. I'm going to keep going. You guys go ahead. Watch the video tonight. Okay? It's going to 0.5. Y equals 0.5. I need you to finish the other page, and I need you to finish this page. Go watch the video for tonight and finish this page. This one is going toward negative 1.67 or negative 5/3. That's where it's going. Okay? This one, 2,000, 4,000, 6,000, 8,000, it's not going anywhere. Okay? It's getting bigger and bigger. So in this case, there's no asymptote. This one, getting smaller and smaller and smaller, and eventually it will go to, well, it will approach 0. Okay? Number 6, can you tell where it's going? Y equals 2.5. This one, getting smaller and smaller and smaller. It's approaching 0. These numbers, 500, 1,000, 1,500, 2,000, as x is increasing, so is y. So it's going nowhere. It's going just bigger and bigger, so that's no horizontal asymptote. So the question at the bottom is there any way to tell the location of a horizontal asymptote just by looking at the function? Before we looked just at the denominator. This time we can't do that. Okay? This time what you have to look at, the easiest one to see is actually number 3. Okay? Because look here. See what my asymptote was? Look here at number 6. Look here. Isn't it another way to write 2.5, 5 over 2? Look at number 1. The numbers in the front, 1 over 1, that equals 1, right? But here's the problem. It doesn't work that way for every single one of them. Like this one, if I just circle that, that's not equal to 0. Okay? So what's happening is that we have to look at the exponents. See, that exponent is 1, that exponent is 1. They're the same. And when they're the same, we can look up here. Okay? This exponent is 1, this exponent is 1. They're the same number of the highest exponent, so we can look up there, we get 1. On number 6, this exponent is 2, this one is 2, but what matters is that they're the same. When they're the same, I can just look at the numbers in front. Okay? The other two choices are that they're not the same. Here, this one is 2 and this one is a 1, and we've got none. Here we've got this one a 2 and this one is a 1, and so it's y equals 0. Okay? So we have to have some way to know the difference between the two of those. We have to know the difference between the two of those. And so, excuse me. Hey, stop talking, please. First of all, we have to look at the exponents. That's what we did over here, right? After I showed you, we looked at the exponents and noticed things about them. When we look at the exponent, we find the greatest exponent in the numerator and the greatest exponent in the denominator. Those greatest exponents are called the degree. Here's the one we just talked about. When the degrees are the same, you look at the leading coefficient of the numerator. That's big vocabulary words for math, but all it means is the one, if it's in order, if the exponents are written in order, it's the one in the front. It's the leading one. Okay? If the degree of the numerator is greater, okay, like this one, degree of the numerator was greater. See, this is a 2 and this is a 1. Look, there's no horizontal asymptote. Okay? The other possibility is that the degree of the denominator is greater. When the degree of the denominator is greater, like this one, the degree is 2, the degree is 1, the denominator is greater, we have an asymptote at y equals 0. Okay? So some sample problems. The degree of this numerator is 2, because that's the highest exponent. The degree of the denominator is 2. That's the highest exponent. What do you notice about these numbers? They are the same. When they are the same, we look right here at the leading coefficient. So y equals 3/5. Okay? Look here. The degree of the numerator is 2. The degree of the denominator is 1. So the degree of the numerator is greater, like this one right here. So numerator is greater. When the numerator is greater, there's none. There's not a horizontal asymptote. Problem number 3, degree of the numerator is 1. Degree of the denominator is 2. So the degree of the denominator is greater. When the degree of the denominator is greater, when the degree of the denominator is greater, we have an asymptote at y equals 0. Okay? And the last one, degree of the numerator is 3. Degree of the denominator is 3. That makes the degrees the same, which means we look at the front, which gives us y equals 4/2, which means y equals 2. Okay? Peace.